Okay, so Gardner designed three square gardens that are joined at vertices to form a triangle. More specifically, a right triangle. This is right. Ooh, let me see the letters. R. Okay, so in this situation right here, we're going to have this right triangle here. And with the right one across, the one across the right angle, I'm sorry, as you see, this is your A and your B sides. And you always have A squared plus B squared equals C squared. And A squared is this whole thing, which happens to be what? Garden S. So S plus, man, horrible S, sorry. And this is your B, right? And that has to be B squared. B squared is this whole part here, which is garden T, equals R, which is C squared. So off my screen, but the whole C squared, right? So S and T is greater? No. S and T, the two small ones, add up to give you that one. S and T are equal. Yes, that's going to be the one I want. This one says R and S. R and S give you T. No. No. These are just mistakes. Or just, I don't even know what they're doing. Waste of timers. I'm doing the same question again. Alright, same idea. So across the right angle is going to be your C. The ones that make up these right angle are called your legs. The ones that make up the legs are your smaller ones, A and B. And the idea is always A squared plus B squared equals C squared. When it comes to this part right here, the A squared is your D. Plus your E, I guess I can do a capital letter D, right? That's what we have here. So square E equals F. So let's just look for them. The sum of squares of D and F, D and E, out. D and E. It says greater. The D's are greater. That's out. D, E, no. D, E, yes. D and E are equal to F. Yes, so D and E equal to F. That's my answer. Remember, the two smaller ones add up to give you the bigger one, right? Once you see this idea, rectangles and stuff, remember a rectangle has right angles. So they're not showing you this, but they're letting you know that for sure there's a right angle in here. Because when they say rectangle, what a rectangle is, has 90-degree angles. Opposite sides are parallel. This is parallel to this one, this is parallel to this one, right? But right angles is the one we need for this one right here. So we have this right angle idea. We know this part over here, which is SU, happens to be your C. The longest side has to be the one across the right angle. And that is going to be your A, and that's going to be your B. So we're going to go with 9, or the formula is the Pythagorean theorem, A squared plus B squared equals C squared, which the situation is going to be 9 squared plus 12 squared, and that's equal to SU squared. Let me see, SU, out. I think it's this one right here. Yeah. What's the difference now? You want to add one. Okay, so remember this small, if you look at it right here, this small square plus this other smaller square, or not smaller, but another small square, is equal to the one that has the bigger side, see? Oh, same idea, guys. Same idea again. Once it's here rectangle, you want to think of right angles here. And so the which one? Let's see, is there something here? Okay, so parallel. So which statement proves the parallelogram PQRT is a rectangle? For that happens, the rectangle has to have a right angle here. Actually, no corners. So regardless, in this situation here, if that's a right angle here and this becomes a diagonal, this forms a right triangle. And that triangle will be coming off the idea of A squared plus B squared equals C squared. And we're going to go with 8 squared plus 15 squared equals the one across is your C squared. And then that one is a QT or TQ, it's the same thing. We're going to go ahead and be GQ. Looks good. Oh, this is wrong. Should be adding nothing squared, nothing squared. Checks out. 8 squared plus 15 squared equals TQ squared. Perfect. Check.